Alright, hi, operations maintenance diesel electric tm55202 chapter 14 trucks. 129 conventional trucks. Swivel trucks are used on almost all small types of diesel electrical locomotive. Each of the truck of the center plate, which supports the superstructure, allows the truck to swivel freely on the curves. Small locomotives on the short wheel base usually only have two axles, may be built with their own running gear, and is used on the cab with the cab frame. The truck must carry the weight of the superstructure vertically, must absorb the lateral thrust and support the tilting tendency of the locomotive. It must transverse up and even with the distance, torsion, excessive stress, and any of the members must carry the brake rigging, must carry the motors electrically driven. The locomotives must be different. The type of the trucks have been designed to meet the great variety of the conditions. The principle of the type of the truck's locomotive larger than 40 tons of the four-wheel rigid truck for the four-wheel swing of the bolster and six-wheel spring bolster trucks in all types. Truck bolsters with the the center bearing having the removable plate of the mates with the body bolster to carry the superstructure. Side bearings, removable wear plates mounted between the underframe, truck frame, and to limit the tilt of the superstructure. The guide extends for the frame of the whole of the journal boxes are in called pedestals. Pedestal liners are where the plates renewable compensate for where they should be kept lubricated, reduce wear. Some locomotive safety chains attached to the corner of the truck underframe to limit the swing of the truck in case of the derailment. If the swing is otherwise limited to the linkage, it is called an anti-slewing or anti-sway device. Other details are described below. Four-wheeled rigid to bridge trucks. The bolster frames are cast or together with the rigid only lateral motion and provisions. In the journal box. Spring coil springs rest of the pockets inside with the pedestal jaws. Additional support is provided the spring typical semi-elliptical under the side of the frame. Rest of the hanger between the equalizing extending between the journals. All wheels or drives or some of the small locomotives have one of the motor in which with the case of the motor is geared with the axle side of the road connect the two pairs of the wheel. The four-wheel swing bolster truck. The principal difference between the swing and the bolster and the rigid bolster truck. Independent suspension. The permitting lateral motion of the bolster. Respecting the truck frame. Riding the qualities improve the boat because the bolster absorbs the lateral loads between the truck and body. They are better suited to the heavy road surfaces. The triple coil springs set for the elliptical swing are often used. Six-wheel swing bolster trucks. Six-wheel trucks distributed the locomotive weight evenly among along the railway to then do the four-wheel trucks. Most of the wheels are driven wheels in the large locomotives, but some of the middle-sized locomotives are light. Track can be obtained with the traction effort for four driving wheels, in which case the extra pair of the constitutes idling wheels. The trucks with the idling wheels are similar than 1 in 6 drivers. Since one of the motors is unlimited with adjusting brakes rigged and provided with the take above slack cleans and water with the brake shoes compensation brake shoes and the turn wheel to accomplish for the adjusting hand of the slack adjuster changing the pins from one hole of the brake levers to the other or both. Brake cylinder position to travel and measure the locomotive air brakes set at 3 to 5 inches allowable. General minor brake adjustments of locomotives using the hand brake slack adjuster may be made while air brakes are set. This is done by cooling out the closing the cutout cock application lines of the brake cylinder, thus releasing the brake to the cylinder truck being worked on. This right here is a truck. We're going to turn it around. This is a four-wheel diesel electric locomotive truck with the brake cylinder with the bolster, the center plate, the brake cylinder, both brake cylinders on both sides, and with a brake lever hooked up to the brake cylinder, rubbing against the truck for the truck wheel and the truck motion power cable. You see the brake hanger and the brake shoe with the brake cylinder pushing on the brake lever, while the truck axle and the frame and the journal boxes are still attached on there. The hand slack adjuster is used to take up the slack of the braking wheel and cause the brake shoe and to keep the brake cylinder. The piston travel consistent with the brake cylinder. Piston travel should be adjusted to the maintenance point of replacing the worn shoe, the brake lever, the piston necessary to leave the hand slack. Adjusting the near travel as possible adjustment that may have to be made in the routement can then be made to the hand slack adjustment without necessary changing the pins on the roads. The hand slack adjustment at the 8-inch travel enough the adjustment to wear the brake shoes down complete with the condemning of the limit of the steel mill maintaining 2.5-inch piston. Travel in the pins and bushings are not badly worn. The automatic slack adjuster they use an additional hand slack of the adjuster of the six-wheel truck passenger locomotive. The function of this device is to take up automatic slack in the brake rigging and the shoe while the locomotive is in the route of the sustained high speed long distance within the subsequent heavy braking. Also have maintained constant piston travel out throughout the travel. Brake adjustment. All locomotives should be made in the main and reserve air pressure to the pump with the making an adjustment to brake release in the handbrake of the and set an independent brake valve application and setting the locomotive brakes. There is no necessity to apply the release of the brake adjustment as are being made for the safety reason. The brake adjustment are made for the cutting of the applicable truck. With the three-way out of the cut located in the body over the heat of the truck. The wheel set are assembly for the two wheels of each, generally considered the wheel set of the railway. Paracells are for diesel electric locomotives. The axle gear is mounted on the axle step of the idler. Wheel set is used in the six-wheel trucks. The idler wheel is designated because it's mounted for the no traction motor, or mounts with no traction motor. Its purpose is to help equalize the weight distribution of the locomotive. F. The axles are usually carbon steel forged, and many axle specification varies in surfaces where the journal box of the friction type of the provision may be the lateral thrust by collar each end of the axle. Roller bearing the type of the axles have no collar at each end of the journal. Axles manufactured 6 classification based on the journal sizes designated A through F, or 3 3/4 by 7 inches. By 6.5 to 6.5 inch by 12 inches. Only the larger size of the found in diesel electric locomotive trucks. Multiple gauge trucks. General multiple gauge trucks is designated to permit adjustment of the wheel spacing and accumulate diverse divide using the locomotive of the different truck gauges. The military railway switch or military gauge diesel electric locomotive has 2 6-wheel trucks which are traction motive on each axle. Since the truck was designated primarily for the military various parts of the world, it had been adaptable to truck gauges. Track gauges of 4 foot 8 inches, 5 foot, and 5 foot 3 inches, and 5 foot 6 inches. The accommodated widest wheel gauge of the frame of the construction for the wider for any other truck and under the locomotive for the field operation, while the set already assembled for the available differential gauge of the facilities wheel work are available. The standard specification wheel set can be expressed and gauge required. Changing the wheel gauge necessity, changing the brake rigging, sandpipe, the conforming the wheel space, then these components are so designed that they can be readily changed. The step necessary to make these changes discussed below. The frame. The frame in Figure 77 of the steel casting has 2 sides of the frame connected with the center of the 2 transform. The crossmember of the transform having 4 spring pockets cast at the 2 near junction side frame spring of the loaded work stabilizer plates and the uprighting protection at these points. The single brake hanger proposes the cast integral strands form onto the 2 each of them to the pipe of the transfer. One of the end of each of the transforming the pocket of the lateral shock absorber central located on the top of each of the transformer to each side of these parts of the pedestal jaws. The 2 spring jacket can cast integral to the spring of the pocket underneath the side of the frame between the pedestals. See the baluster. It is an H-type of the casting in the center of the baluster is an H-type casting on the center casing casing on the top of the spring pocket. The underneath it is the 4 corners of spring pockets of the rest of the baluster springs suspended the baluster car body of the steel wear bushings. A steel wear bushing pressed in the center of the casting where plates are mounted in the 4 corners of the baluster. This is a truck frame. It shows the side balusters and the center balusters. While it has this is a 6-wheel frame, truck frame. Each edge of the baluster casting rides over the transformation knocked out of it in his overall lateral shock of the absorb. Each of the transformers to take up the lateral and sideways motion of the car body. Wear plates are provided with these points. D equalizers. 4 pairs of equalizers are connected with the journal blockers on each side of the outside of the pedestal. Spring seat bolted between each pair of the equalizers outer pedestal. Each of the 4 seats that carries the 2 single coil springs which the frame rides. The coil springs of the heavy-duty dual coil springs are called boiler springs are used to transfer the weight of the locomotive between the baluster of the frame and the 4 pairs of the single coil springs carry the frame right on the spring of the seat of the bolted between the equalizer. The journal box. The journal box is a plain pedestal type box consisting of a cast wheel housing the dustproof spring closed lid of 6.5 inches to 12-inch journal bearings. The general discussion of the friction bearing box is contained in the paragraph 131. The axles in Figure 80 are tubular extra long and can be used for. Here's the truck frame once again. This is where your truck baluster with a center plate, where they usually have a wheel mounting bearing systems going on. You made the center billing, the knock bolt pin. When spacing 33, when spacing of 53 3/8 of an inch, or 56 7/8 of an inch, or 59 7/8 of an inch, or 62 7/8 of an inch, the wheel seats a portion of the axle to increase with the length to allow the wheels to press to the different gauge width. The journal box is the friction provision that is made by the lateral track of the clutch of each of the end of the axles. Spacers are used while the wheel is changed with the wider gauge. Normally, these three spacers are on the outside of the wheel. Standard gauge of the spacer, three-threaded holes were used to the space of the before wheel and axle gear removal. The space non-threaded all the way through, and is always polished with polished surface, which must be as the motor journal bearing, which then appears as spears, depending on the open gauge of the placed inside. But the wheel of the mounted spacers, the heat of the hot coil, the strength of the place and is indicated with the spacers are removed and using the puller and the brake rigging. The brake rigging is the multiple gauge truck consisting of two 10 by 8-inch brake cylinders mounted on each side of the truck and attached to the two horizontal side levers. The inner end of the cylinder lever attached with the means of the flexible clevis to the top of the two, and the truck lever. The two horizontal cylinder levels are connected with the ends of the intermediate horizontal lever means of the two pull rods. With the necessary pins, the intermediate horizontal pin is provided with the fulcrum between the end of the inner cylinder inner end attached to the mean of the flexible clevis at the top and in the middle of the truck lever. The brake cylinder's horizontal cylinder level is intermediate with the horizontal lever. Necessary lever guides are mounted on the two detachable brake cradles. These cradles are secured with the truck frame and 3 1-inch bolts and are kept in the position of the frame from the shear lug of the frame and each end of the cradle. These cradles have the 12 1 1/16 of an inch hole spaced in the figure 81 as this shows the bearing type journal. You have your dust guard, your bearing journal. You have like basically pin bearings in here in a 6/0 arrangement where you use a hook to hook them out and take them out. There's usually a gasket here and cover. Well, that's backwards. This is where it goes into the journal. The front cradle of the figure 82, the rear cradle, the holes designated ABCD, shown in 81 and 82. The portion of the frame supports each of the cradle provided with 6 holes taped with 1-inch bolts and arrangement shown in the figure 83. The frame under the rear cradle, the tap of the holes designated 1, 2, shown in figure 83 and 84. The three truck levers on each side of the truck of the previously mentioned connected to the top of the end of the horizontal levers mean flexible levers for the lower end of the truck levels attached with the brake head of the brake shoe, the 4/8 of an 4 foot 8 and 8.5 inches of gauge, and nut spring holding the brake shoe brake lever to the outside of the wider gauge. The springs must be inside of the point of the ends of these truck levers attached with the truck frame. The means of 3/4 of an inch diameter pin designated with the U in the figure 85. The pin is secured with a 1.5 inch keep of the bolt and designated in the V in the figure 85. The truck lever is spaced in laterally 4 spaces of W, X, Y, and Z. The same figure R2. Here you see the trucks and like the wheel. Well, the wheel axle assembly with the journal and the wheel and the journal case and the axle. Rear cradle, front cradle, frame of the cradle. Talking about baluster. Or sorry, I don't know. Cradle. A couple different things cradle means, and it could be a crib, I don't know, but we'll see. Alright, I'll start reading again. Once I get 1 1/4 inch and 1/2 of an inch of the respective the inner and then the 3 inch of the pin, which is the 3/4 inch tapped hole in which the 3/4 inch eyeball inserted the facility. Remove the pin. Wheel and axle assembly. The standard dimension between the wheel and the back of the locomotive is designed to operate the 4 foot 8.5 inch gauge track of the 53 3/8 inch from the other gauge specification table and customary to provide the machine surface inside of the hub of the wheel and be used to the heat of the dust seat of the gear case of the traction motor since it's intended with the same traction motor than gear cases. The all gauges are necessary to spacers applied with the wheels in order to obtain a seat of the dust, and hence in order to convert the wheel axle assembly to 4 foot 8.5 inches wider. The gauge required to remove the wheel from the axle. The mounting of the suitable spacer, the reapplication of the wheels, the axles, the equipment for the making of the changes such would be available in the field and necessary to prepare the separate wheel. The axle assemble to complete the gear is suitable spacers for each of the gear, where the axles assembly part of the numbers indicated in table 1. Sanders arrangement for the MRS truck consists of a short piece of 1 inch and the 1 inch pipe welded oblong block to the upper end of the pipe with the fastened flexible rubber hose with the leads upward to the Sanders of the car body. The lower end of the tape of the subpendage suspended directly over the rail in the front of the wheels and kneel wheels and 3 inches above the top of the rail. The sandpipe designated with the A figure 86 and help with the place of the brake mounted to the truck of the tray. Two frames, the E in figure 86 and 3 spacers in B, C, and D. They also provide a sand bracketing. Additional bolt holes F are provided with the sand pipe may be raised for the wheels and turned when the smaller wheels applied. A rail guard. When the MRS locomotive figure 98 is operating the conus, it will be equipped with the forward boards, pilot mounted on the end plate of the customary of the country. The European countries, however, the coupling arrangement will not permit the U.S. conventional pilot. Hence, when used, the pilot will be removed and replaced, regarded with the arrangement similar to those of the European locomotives. The provision has been made of the bolting railroad guarding support designated G figure 86 above on the sand bracket of the two bolts shown in the H. The support of the provided the slots L and M made of the fit of the rail guard. The J, the rail guard hold the place, and two bolts of the K. The rail guard is. This is the truck lever part. It shows the different gauges signed off here, in and out. Sander rail guard equipment. Made straight off the offset of 1.5 inches, the figure 86 of the provision water gauge. Extra holes are provided with the rail guard to raise the wheels and are turned renewed, and wheels are smaller diameters. Gauge changing procedures indicating with the outline sequence of procedure changes. The gauge is in the multiple gauge trucks. In all cases, the in means towards the center line end of the locomotive, and the out means from the center line of the procedures. M8, 9, 10, and 11 below must be performed in the motors or truck. Change 4 foot 8.5 inches to the 5 foot gauge. Remove the pedestal tie bars. Disconnect the traction motor lead wires. Disconnect the flexible clevis top of the truck levers. Remove the wheel and assembly. Traction motor still in place and drop. If a drop pit is available, this may be accomplished supporting the frame of the equalizer while the motor is wheel and axle assembly is lowered off of the truck. If not, no drop pit is available. With necessary to remove the truck of the locomotive to provide suitable support of the motor equalizer, lift of the truck frame of the wheel and axle assembly. Place the wheel and its axle assembly suitable fixture of the hold motor. Remove the axle tabs of the bearings. 6. Remove only the wheel axle assembly number 8175150. Center of the wheel and axle assembly number 8182722 for the motor, and replacing end wheel with the axle assembly number 8175151, or center wheel and axle number 8182774. Replace the bearings and the bearing caps. Remove the brake pin keeper bolt in the V figure 85 each truck lever. Remove the brake pin U figure 85. Remove the spacers X, Y, X and Z figure inside of the brake lever. Spacers Y and W and Y on the outside of the brake lever. Replace the U pin on figure 85 to keep the bolt in V. Replace the wheel and wheel assembly and the motor in the truck. Reapply the pedestal and bars. Remove 1 inch of the bolt in the front of the rear cradles. Remove the two bolts of the brake cylinders, the pipe of the clamp, the bracket, the pump. Push the cradles out into the holes figure 81 and 83 in. Cradles line up the taped holes, the figures 83 and 84 in the frame. Reapply the bolts and cradles, brake and cylinder and pipe clamp, bracket. 15. Connect flexible clevises between the truck level and horizontal level levers. Remove the bolt E. Figure 86 is the standard brake of the place of the spacers B inside the standard brake pocket. Block lever spacers C and D on the outside of the standard block. They reinstall the bolt E. Remove the rail guard K. Figure the 86. Move the rail guard J. And outside of the M of the railroad rail guard support, offset the rail guard supports, turn to the reapply to the K. 18. Reconnect the traction motor leads. To change the 4.5 inch the gauge to 5.3 and an inch for the gauge. Same as M1 and through M as follows as M through 5. M1 through M5, same as. Remove the wheel axle assembly number 8171507, wheel axle assembly number 8182972 from the motor. Replace the wheel axle assembly number 8175152, center wheel and axle assembly number 818228779. Same as the same MS and some MS, same as the MS and some MS8 and MS9. Place spacers at Y and X. Figure to the Figure 85 on the inside of the brake lever, spacers at Y and X on the outside of the brake levers. M through 13 is the same. M through 1, M1, M11, M12, and M13 are the same. Remove the 4-inch bolt in the front of the rear cradles. Remove the 2 bolts from the brake cylinder pipe of the clamp. Press the cradles up into the holes C in Figure 81, 82. The cradles line up the tapered bolts in Figure 83, 84 in the frame. Reapply the bolts in the cradle brake cylinder pipe, clap of the brake, and same as the M13. Remove the bolts of the E. Figure 85. 6 brake side sand brake at the placer spacer B and C inside of the sander block. Leave spacer with D outside of the sander pipe block it and reinstall the bolt E. Remove the rail guard bolt K and figure the rail J so that the offset outward and replace the slot and replace slot L with reapplied bolt K. Same as M18 to change from 4/8 of an inch to the gauge 5/16 same as M1 through M5. Remove the wheel and axle assembly number 8175 150 center wheel axle assembly 8182772 for motor and replace with the end of the wheel axle assembly number 8175153 or center for wheel and axle number the 8182778. C is MS through M9 is the same. Spacers X, W, X, Y, and Z figure inside the brake lever. M1 through M13 are the same. Remove 1-inch bolt in the front of the rear cradle of the 2 bolts. Brake cylinder pipe back at the cradles until the D figure is 81 and 82. Cradles are lined and tapped in the tapped holes 2 figures 83 and 84. The frame reapply the bolts of the cradle and the cylinder pipe of the clamp bracket, same as M15. Remove the bolt E in the figure 86 of the sand bracket. Place the spacers B, C, and D. The figures 36 inside the sand pipe. Break it and reinstall the bolts E. Remove the bolts K. Figure with the 36 and remove the guard J and the M outside the railroad and turn outward to reapply bolts in K. Side same as M18. Specification tables illustrated in Table 1 presented here in the summary. The position of the various parts should be in operation of the MRS locomotive truck for various gauges. You see the 4 and 8, the 8 of the inch gauge with the 4 5'3" inches and 5 6 inches in the gauge. It tells you where the wheel spacing is, the cradle hole and its number, its letter, and hole in how many numbers are hole in frames. The spacers inside the W, X, Y, and Z if they're all in contingent, or just W, X, or XZ, or none, and then flipped around to the spacer outside W, X, Y, and Z for the. And then W, Y, Z, and 9. The wheel assembly numbers, end and center. The spacers outside and inside, and the rail guard slotted offset and slot and offset. 131. Journal box is friction bearing. The journal box consists of the cast steel holes in the dust for the spring closed with the wedge. The journal bearing thrusting in the bearing, dust guard spread, bearing packing waste, and additional baskets, locking wire. The bolts are a special case of the thrust bearing letter roll spring back in the addition added figure 79. The channels to each side of the journal box to fit over the truck. The pedestals holding the journal box in place. The frame of the tie bar is across the lower end of the pedestal that serves as the reinforcement of the pedestal that prevents the journal box to pull dropping out of the pedestal in case of the derailment. The wedge forwards the solid contact between the box and the bearing. If in the small furniture is easily inserted, remove the journal bearing and the bronze back rabbet solid type bearings rides on the top of the side of the axle journal while the radius turned toward the wheel. The thrust bearing of the thrust block is sometimes called the steel casting with the bronze face. Is located in the front of the part of the journal box. The contents contacts the end axle, the lateral thrust exerted in all houses, the lateral spring and the subner, lateral springs and oil passes are stored and recessed in thrust bearings hose housing the bearing surface for lubrication and supplied by oil-soaked cotton and wool waste mechanical lubricated devices. The dust guard fits in the slot of the back end of the journal box. The journal box is assembled with the axle of the journal. Dust guard fits in the shoulder axle near the wheel to prevent the oil from leaking off the box. It also prevents the dust and water from entering the box. Oil-soaked spring packaging waste and lubricating device is placed on the bottom of the housing and axle wheel. Oil-soaked and cotton wool waste is placed in the recess of the throttle bearing, provided lubrication between the thrust and bearings of face face of the axle. Okay, 132 journal box rolling bearing. Rolling bearings consist of the heavy cylindrical inner and outer races. The two rows of large diameter solid rollers are races of the fabricated hardness of alloy steel. The inner race of the shrunken axle journal. The wheels may be removed from the distributing inner race. The rollers cylindrical and flat ended retained the one piece of each of the bronze categories for each of the bearing contains two rows of rollers and space and longitude floating plate space ring of the contacts of the rollers and the outer racers driving the journal box. And the rollers are retained in the proper longitudinal position. Hardened surface of the retainment. The rings of retainment surfaces contact with the ends of the rollers only. The journal boxes must be fitted in plane. The combination of the cover of the plane covered the non-provision auxiliary attachments, whereas combinations covered the fitted with the attachment speed indicators, rivers and drivers, brake speed generators, overspeed controls, attachments, similar devices. Journal box housing in case of the store casting board of the receiving the outer bearing race, retaining the ring oil sealing bushing if used in the center of the front of the cover, front cover, and retainment ring. The lower portion of the housing of the form of the oil reserve sump of the pedestal weight. The sides of the housing are lined with renewable where the plates are welded in place. The top of the housing of the set and the sub equalizer depression housing are provided with the application of the heat indicator. The outer inner retainment, the ring of the iron casting outside of which is turned off the inner board of the housing. It fits between the end of the outer race and the shutter holder at the end of each of the housing board and is perverted and turned in the engagement of the oil bore spout of the boss is cast inside the housing groove, the retainment of the conducting and lubrication of the roller bearing, the operating cavity of the thrust block. The thrust block of the case of the hard bronze is mounted on the inner side of the front of the cover. The thrust cover block is designed for the lateral clearance between the face and the end of the axle to allow the axle to float internal with the truck slim. An adjustment is provided to maintain any desired lateral clearance between the end of the axle and thrust block. The thrust block receives the entire lateral thrust in the axle. An oil seal bushing pressed in the inner housing provides the oil seal entertainment. Inner retainment forces the roller assembly does not touch the axle, therefore nowhere inward extending the flange surrounds the inner race of the smaller flange. Smaller surfaces oil which purchases the flung outward centrifugal forces. Annual spacers provided with the oil seal bushing catching the oil drain in back of the oil reserve. The pressure prevents the oil from collecting in the upside of the baffling, interrupts the upward surge of the oil from the reserve. The rear of the housing inside of the diameter oil seal bushing shrouds deserted guard diameter at the axle clearance. 133 the flange oiler. The flange oiler is provided with some equipment operating the number of sharp curves. Oil flange reduces wear on both the flange and the rail and reduces the tendency of the wheel to ride up or override the rail. Flange oilers can be installed with the track on locomotive. Those locomotives are mounted on the track. Lubricating in the specified grades should be fed in limited quantity. The fed stick should be rided the correct part of the flange. Part 5. Operation Diesel Electric Locomotives Operating Instructions.